So the question is how to visualize the data appropriately. The frequencies that we have already studied are usually displayed in tables or figures or charts. Often both are produced together. That is why when we visualize data we have to adhere to the principles of charts. Charts serve for visual expression of information from extensive data sets, especially for those persons who are not capable of grasping the quantitative meaning of numbers from tables. Therefore, in principle, charts must be designed simply and must be immediately comprehensible. Charts which strive only for impressive effects but detract from or even hide the essential information are therefore counterproductive. We will take a close look at the pie chart, histogram, bar charts, three-dimensional block diagrams, and the dot diagrams, histograms, and box plots. The calculation of cumulative frequencies does not make sense in the case of nominal scaled characters, since their values are not allocated in ranking order. Therefore, we use a pie chart to illustrate absolute and relative frequencies of a nominal scaled character's values. A pie chart or a pie graph is a circular statistical graphical chart which is divided into slices in order to explain or illustrate numerical proportions. In a pie chart, central angle area and an arc length of each slice is proportional to the quantity or percentages it represents. Total percentages should be 100 and total of arc measures should be 360 degrees. Here is an example of the use of a pie chart to illustrate the percentage of observed values of the nominal scaled character social status. And another example, the table contains absolute frequencies of the values, and on their basis, relative frequencies and hence percentage of the values were obtained and illustrated via the pie chart below. A bar chart is a graphical representation of values as bars. Each bar's height is proportional to the value frequency. A bar chart can be plotted vertically or horizontally. In the case of ordinal scale characters, we prefer to use the bar chart and the dot diagram instead of the pie chart, as it is not possible to represent the rank order of the observations with it. A bar chart, as we have seen so far, is also very convenient for representation of cumulative frequencies and cumulative percent. Here is an example. The bar chart is used to represent absolute frequencies of the values of the character church attendance. And now we use a bar chart to visualize cumulative percentage for the values of the same character. A bar chart can also be used to compare frequencies for the values of characters within two different samples. For example, we have two samples. One represents children with Turkish as a native language, and the other comprises German-speaking children. We use this bar chart to compare the absolute frequencies of sibling numbers among both representatives. Children from both groups are supposed to have some number of siblings with ranges from 0 to 5. If we look closely, we can also see that in this case the bar chart is also used to measure frequency distribution for two characters, namely nominal language of a child and a quantitative character number of siblings. If we replace bars with dots, we obtain a dot chart or a dot plot. Just as bars, the dots can be arranged either vertically or horizontally. Each dot is positioned in a chart to illustrate a value's frequency. A dot chart can be plotted, can be used for representation of absolute, relative, cumulative frequencies of ordinal scale characters. In this example, the dot chart is used to represent absolute frequencies of the values of the character church attendance, and the mode, so the most frequent value, is represented by the most distant dot. In Quantitative characters, they rarely equal outcomes. If there is a sufficiently high measurement precision, thus several measurement values are often plotted together into classes. This is how continuous variables appear, and a histogram represents probability distribution of a continuous variable. These continuous variables are allocated along the abscissa and are depicted through rectangles. The heights of the rectangles correspond to relative, absolute, or cumulative frequencies allocated along the ordinate. Here is an example of histogram used to illustrate absolute frequencies of different gross monthly salary values. Here is another example. Every month, one measures the amount of weight one's dog has picked up and gets the following outcomes. We put these numbers in order from the lowest to the highest weight gain. We put the results into groups of zero point 0.5 and build a histogram to see that most frequently the dog experienced the weight gain up to half a kilo. There are no values from 1 to just below 1.5, but we still show the space.